And when they are, they're already expensive. Picture this: a brand new $1 million forklift loaded down with thousands of pounds of product, rattling and shaking its way down an aisle. The operator is fighting the wheel, the mast is vibrating, and the whole machine looks like it's on a rodeo ride. This isn't a scene from some back alley operation. This is happening right now in modern distribution centers all over the country. The culprit isn't a faulty machine or a bad driver. It's the floor, an uneven concrete slab, just a few millimeters out of spec, is enough to turn a precision machine into a bucking bronco. The stakes are simple, and they are high. An uneven floor puts your people, your equipment, and your entire operation at risk. It's a foundational problem that ripples upward, costing you time, costing you money, and costing you peace of mind. That vibration translates into wear across components, from tires to sensitive electronics, driving up maintenance costs and leading to unplanned downtime. A sudden lurch shifts loads, damages goods, or worse, triggers a safety incident. We invest in software, robotics, and high-tech racking, but overlook the surface everything relies on. If your floor isn't right, nothing else can be. Autonomous systems follow precise paths within tight tolerances. An unexpected dip or hump throws off navigation, damages wheels, or shuts systems down. Close enough isn't good enough. The technology exists to remove guesswork, see the entire surface, measure every deviation, and get ahead of problems. It's time to stop accepting the shaky truth of uneven floors and demand a foundation built on hard data and absolute certainty. When we talk about a flat floor, what are we really talking about? It's not about being perfectly level like a billiard table. The industry has two key measurements: floor flatness, FF, and floor levelness, FL. Levelness, FL, slab tilt or slope over long distances. Flatness, FF, waviness over very short distances, the jarring, wheel-rattling imperfections. These numbers are defined by standards like ASTM E1155. Picture a straight design line over a wavy as-built surface. The distance between them is the deviation. In millimeters, we're talking millimeters, not inches. 5 or 6 millimeters, less than a smartphone thickness. We can visualize deviations like a weather map: green good, yellow borderline, orange caution, red problems. Those red zones are bumps that jolt forklifts and dips that misguide robots. A visual map of risk. Stop thinking, it looks flat. The eye can't see a 4mm dip over 10 feet. Spot checks miss subtle issues. The foundation of a modern facility isn't just concrete, it's data. Measure the millimeters that separate smooth from struggle. Deviation equals risk, and it's time we started measuring it properly. A building owner or warehouse operator might not be an expert in concrete, but they are an expert in costs. An uneven floor is a hidden tax on everything that happens within those four walls. It directly impacts forklift and AGV stability, automated equipment performance, and raises total cost of ownership. Uneven floors accelerate wear. Tires go faster, load wheels chip, electronics suffer, hydraulics take a beating, leading to breakdowns and costly repairs. Automation relies on floors that meet strict specifications. A deviation can cause positioning loss, grid traffic jams, or even a system halt. Fixing an out-of-spec slab before racks go in is one cost. Fixing it after, unloading, grinding, disrupting operations, can be 10 times higher. If you don't fix it, you still pay. In maintenance, lost productivity, damaged product, and constant safety risk. Owners care about flatness because it's not a construction detail. It's a fundamental business variable that impacts the bottom line year after year. For as long as we've been pouring concrete, we've tried to figure out if it's flat using straight edges and dipsticks. It's slow, tedious, and labor-intensive. After a day, you still get a fraction of the story. Data points, not the whole picture. Sampling measures specific lines and hopes they're representative. But defects can hide between those lines. It's like trying to understand a landscape through a drinking straw, prone to human error and late discovery. Now contrast that with the new way. A single operator scans with a modern laser scanner, Leica or Topcon, capturing millions of points in minutes. The device builds a complete three-dimensional model, a digital twin of the entire floor surface. Software automatically analyzes the data against project specifications and ASTM E1155, generating a report almost instantly. Split, sampling versus full coverage. Move from spot checks and arguments to a color-coded heat map everyone understands. The conversation changes from "I think" to "the data shows a 7mm deviation in aisle B12. Here is the exact location." It replaces ambiguity with irrefutable data. The journey from a freshly poured slab to a clear, actionable report is faster than ever. A simple three-step workflow. There's no fluff, no complicated procedures, just a straight line from reality capture to a definitive result. Step 1 is capture. A terrestrial scanner or mobile device systematically covers the area. The scanner emits millions of laser pulses. Time-of-flight returns produce precise 3D coordinates. The result is a dense, highly accurate point cloud, a digital replica of the floor. Step 2 is analyze. Upload the point cloud, define the area, click Analyze. You don't need to be a software engineer. The software compares millions of points to a theoretical plane, calculates FF and FL, and generates a heat map in minutes. Step 3 is decide. The software outputs a clear report, heat map, FF, FL, and tolerance compliance, so teams can act immediately. With everyone aligned on facts, you can schedule grinding while crews are mobilized, replacing deliberation with decision and saving time and money. A modern floor flatness report is more than a pass-or-fail grade. It's a diagnostic tool, understandable and actionable. Done right, it becomes the single source of truth, eliminating he said, she said, with verified facts. The centerpiece is the heat map. Green intolerance, yellow borderline, red failures. Alongside it, official FF/FL numbers measured against project specs and ASTM E1155. Break the results down for the overall slab, forklift aisles, and robotic zones, where work actually happens. A clear tolerance table shows required versus measured values with simple pass-fail indicators. Great reports translate data into direction. A list of out-of-tolerance zones with exact locations and severity. For example, aisle 4, 50 feet from column C, high spot plus 8 mm over 10 feet. Grinding required. This turns a report from a record of the past into a work order for the future, enabling surgical fixes with minimal wasted effort. In construction, disputes are expensive. Delays, strained relationships, and legal battles. Manual spot checks invite disagreement. 2 measurements, 2 stories. Automated reporting changes the game. A full coverage laser scan is an impartial, digital witness. Share the report and everyone sees the same facts. The conversation becomes how to solve what the data shows. QA reviews the FF/FL numbers. If they meet spec, the report is attached to sign-off, creating a permanent, traceable record. It protects the contractor and gives the owner certified assurance. Scan right after a pour. The report flags high spots in a critical aisle and goes to the concrete contractor the same day. The crew returns next morning, grinds the highs, and a quick rescan confirms the fix. Minimal cost. No schedule hit. A future equipment damage claim avoided. Proof is cheaper than litigation. The floor is the most used and most abused surface in any industrial building. It's the literal foundation of your operation. For too long, we relied on incomplete data and slow decisions. That era is over. Automated floor flatness analysis with laser scanning isn't futuristic. It's practical, affordable, essential. It replaces guesswork with data, opinion with proof, and reactive fixes with proactive QA/QC. Save time, cut costs, reduce risk. If your team still walks floors with dipsticks, you're behind. Start with one slab. Book a scan, get the point cloud, run automated analysis, generate the report. Put the heat map on the table and watch the conversation change. A report in minutes prevents weeks of arguments. A small early fix can save tens of thousands. Prove value on one slab, then scale to every slab and build flatness checks into QA/QC. If you're still measuring slabs manually, You're already behind. Beat. Start with one slab. Scale to every project. Start with automated floor flatness. The data is there. Start with one scan. Prove compliance. Prevent a claim. Save money. A modern, efficient, safe operation starts with a flat floor. Treat it with the data it deserves.